Hello everyone. In the previous video, we saw how to implement this for each functionality so that we can apply a function to all the elements of a tuple, effectively iterating through the elements as we have it, as you see here, printing the arguments basically to standard out. So one thing we could point out about this function is that we are essentially applying a function, but we're basically throwing away the result. So if this function was more than a print and was doing something useful to the arguments, we at the moment don't have a way to collect them or do anything with them and be able to retrieve this result. So this is what we're going to do in this video. So we want to implement a functionality that let's call for the moment Fmap, because that's the functional programming name sort of that we give to this sort of functionality. So what we'll do is we'll define Fmap like this. So it's going to take again a callable F, and in this case, it's going to take a parameter pack of all the tuples. So what we really want to be doing is we want to first check that all the tuples have the same size, because what we want to apply is, if we have, for example, these two tuples here, we want to apply a function and have it take the first argument of one of the tuples and the second argument of the other tuple, or more if we have more tuples, and we want to apply like this vertically. So in this case, we want to do something with like the 10 and 20, and then another one with the 10 and 5.5, then another one the hello and world. So let me implement basically first something that would allow us to print these two things to the output, essentially doing something with both of them, but still without taking the results. So we can see how we can basically implement the basic functionality. So what I want to be able to do, I'm just going to paste something off screen here. I want to take this same tuple, T in this particular case, and I want to do this. I want to have an fmap function that's going to take, since we're passing two tuples, the same one in this case, but doesn't matter, I want the function to take two arguments. So I would like this to iterate through all of the elements of the tuple and call this function with one element of one and one element of the other. In this case, printing, in parentheses, the first value and the second value in all new lines. So let's try to see how we could implement this. So at the moment, this is compiling because my fmap is not really doing anything. So let's think how we can actually do this if we take some inspiration from our previous implementation. So we actually want to be taking each of the elements of the tuple. But in this case, I cannot really use apply, because apply is going to take one tuple and expand all of the elements into the arguments of one function. So what I really want is I want to take these tuples and somehow first detect that they're all the same size. And we'll see how to do that a little bit later, because if we're calling them with the tuple of the same size, it's going to be okay for now. But what we want is to say, okay, my size of the tuple is going to be some size t size, right? I want to say I am going to do standard get of, if the tuple size is 4, I'm going to do standard get of 0 on all the tuples and use that as arguments to the function. And then standard get of 1 with all the tuples and do that as arguments to the function. So let's think about for a moment what we really need here. The first thing we're going to do is we are going to try to get the size of this tuple. And for the moment, we'll assume they're all the same. So there's a functionality that we can look at here that it's called tuple size. Tuple size. That we just pass one of the types and we get the value of the tuple. So what we need is to find the tuple size of all the tuples, right? So one trick we can do here to both ensure the sizes are all the same and obtaining them at the same time is to do like this. We can, first of all, think about this way. We need tuple size here. We need tuple size on something, right? So I would like, for example, to be able to index into the pack and say, give me the TS of the first one, and I'm going to assume that's the value. But in C++23, we don't really have this functionality yet. That is going to come, but for the moment, we don't have it. But what we can do is we can say, okay, let's generate with the same trick of comma and folding operation, let's generate in an initializer list of all the sizes, right? So we could say tuple size of, and for clarity, I'm just going to do remove all the reference or our RF qualifiers, and we could say, let's take all the tuple sizes of all these parameter packs and expand them. So this is not going to compile, but essentially I have them all. So what I can do is I can use an algorithm, in this case, the min-max algorithm, that's going to scan through all of the inputs that I give it and find me both the minimum and maximum. For reference, let's just look it up here. Min-max. And fortunately for us, we can pass an initializer list, and it's going to give me a pair of the minimum and the maximum of the values. So if we do that, we can get the following. We can say, okay, because I need this at compile time, I think I'm missing a T, const expr auto pair T min max, and this is going to give me a pair with the minimum and the maximum. So what I would expect is both of them to be the same. Now, I can't unfortunately do this because that's going to give me an error in which I can't really have a const per structure binding. So that's not quite possible. But if I have the P, I can simply extract them like this. I can say, I'm going to get the first of the pair, which is going to be the minimum, and the second of the pair, which is going to be the maximum. And I can static assert that both of them are the same size. And now I have them. Either min or max will be my tuple sizes. So with this, what I can do is say, well, now I know what the tuple size is. So, and I'm going to need, if we think about delegating this to an impl function, I can do const per fmap impl. I need to have both, let's put the template here, the callable, and I also need to have all the parameter packs. But I also need a parameter pack that's going to tell me each of the elements of the tuple. So if we have a tuple that has, size 4, in this case, I need a parameter pack with an index sequence of 0, 1, 2, and 3. And then I can expand that sort of parameter pack and do something with it. So I can write an expression that is going to take the 0 and do something to all the tuples, the 1, and so on. So the trick is to do the following. Is to say, well, I am going to have a parameter pack, right? But I need to be able to deduce these i's. So what I need to do is I need to take the same callable that we had before, but I also need to take an index sequence with exactly this parameter pack. So let's define it here. And then the same tuples. So before calling it, what I can actually do is right here in Fmap. If I want to have the result, I want to call this Fmap implementation with an index sequence, I can use this min to make one form. So what we are going to do is we're going to type Fmap. And for the moment, I'm not going to worry too much about forwarding. As we said, we don't really need in this simple example. But what I can do is do make index sequence. We do like this. And then we take the tuples and we expand them all. Now we're delegating to this fmap impulse with these tuples. Now, what can I do once I have the index sequences? I can make myself a helper function that I'm going to call. I'm just going to write it right here. I'm going to call invoke at. That is going to take all of the tuples and it's going to just take one index. And this is simply going to invoke the function f with the ith element of all the tuples. So the signature is pretty simple. It's just this return, and for generality, sorry, I'm going to use invoke, standard invoke, f, and here I can do standard get I of the tuples. And I'm returning the result. So for the moment, I am now achieving what I want, which is not throw away the result. But still in this fmap, I need to actually use this. So how can I use it? Well, I can make use of fold extractions again and say, well, I'm going to return a tuple of all the results of the application. And due to constructor template argument deduction, I can initialize the tuple like this with this invoke at with this I. I need to expand this parameter pack, but we'll do that in a moment. And what I need to pass is I need to pass the f and I need to pass the tuples. So I pass all the tuples and I expand them, and then I expand this second parameter pack that I have here right into the result. So let's just see what I'm missing here. This compile error, instantiation of const expr, invalid use of void expression. Right. So this is the problem that I was waiting for us to have, which is I am basically constructing a tuple, and whatever this invoke at returns, I'm going to use that to initialize the tuple. In this case, the invoke at, when I call it with a function that doesn't return anything, the return type is still going to have certain type, but it's going to be void. So I can't quite construct a tuple of void. Luckily, I can do a trick. In invoke at, I can say, well, if this expression of invoking f with tuples actually gives me a return type that is void, I'm not going to return it directly. I'm just going to execute it and then return some token type that I'm going to invade from here. So what I do is I'm going to invent this void tag structure. And here I can say the following. I can say if const expr. I need to check if is void v. So what is void? If the invoke result of what? Of the callable C with the result of doing get of the C. Actually, sorry, this should be on the invoke at and not in the tuple. If this result with the standard get of the tuples, and I expand them all to be able to say, well, the result of calling this, if that is void, then I'm simply going to just invoke and not actually return this. And what I return is this void tag. But since this is going to be executed anyway, I need to actually put this in an else. Right there. Now I'm getting invoke at with, either a void tag or the actual return tag. So here we see back here that I'm actually implementing the function that takes both of the values from, in this case, my tuple, and I'm just printing them one after another. 42, 42, 52, 52, hello, hello. Now, if I had these two tuples, for example, I could do something else. And I could say, I'm going to implement the fmap, and I'm going to return a tuple with the result of adding them both. So in this case, I'm going to get 10 plus 20, 10.0 plus 5.5, and hello plus world. So all of these types in double and string have overloaded plus operator. And then I can use this for each print again. So if I print it, but I pass this tuple at the end, what we should see is that we will get printed after it compiles. Let's just give it a moment. We will get printed 30, 15.5, and hello plus. So there you have it. That's the implementation of fmap. Very useful when you have to manipulate different types together from different operations, and you need to functionally organize them into some other operation that you can do. You can use this pattern. Hope it was helpful, and as always, I'll catch you in the next video. Thank you.